In this video, we are going to talk about inverse Laplace transform. The inverse Laplace transform of a function f of s is denoted by f of t, and it is given by f of t is equal to L inverse of f of s. We have already learned Laplace transform. We know that Laplace transform of a function f of t is equal to capital F of s. So by getting Laplace inverse, we do the reverse process. Like Laplace transform, in Laplace inverse Laplace transform also there are standard results. So you have to remember the standard results before we are going to the problems. Result number 1, L inverse of 1 by s is equal to 1, because we know that Laplace transform of the function 1 is equal to 1 over s. Okay, so if I take L inverse for this one, that is L inverse of 1 by s is nothing but this value 1. Say for example, if I have L of e power at is equal to 1 by s minus a, then L inverse of this value 1 by s minus a, that is going to be equal to this value e power at. Okay, so L inverse of 1 by s power 2 is t. L inverse of n factorial by s power n plus 1 equal to t power n. L inverse of 1 by s minus a is equal to e power at. L inverse of 1 by s plus a is equal to e power minus at. L inverse of a by s squared plus a squared equal to sin at. L inverse of s by s power 2 plus a power 2 is equal to cosine at. L inverse of a by s power 2 minus a power 2, that is equal to sin h at. L inverse of s by s squared minus a squared is equal to cosine h at. L inverse of 1 over s minus a the whole power 2 is equal to t into e power at. So before going to the problems, I ask you to remember all these standard results. Then only we can do the problems in an easy way. Let us move to the problems. Question number 1. Find L inverse of 1 over s minus 3, 1 over s by s squared minus 4. So we have three terms. So we have to apply L inverse for each and every term. So the first term will become L inverse of 1 over s minus 3 plus L inverse of the second term 1 over s plus L inverse of the third term s by s power 2 minus 4. So by using L inverse of 1 over s minus 3, we come to know the result is e power 3t plus L inverse of 1 over s is going to be 1. Then here we have s by s squared minus 4. This 4 I can write 2 power 2. So if I take L inverse, this will become cosine h 2t. Question number 2, L inverse of 1 over s power 2, 1 over s plus 4, 1 over s squared plus 4 and s by s squared minus 9. So we have to split every term and we will take L inverse for each and every term. So first term will become L inverse of 1 over s power 2 plus L inverse of 1 by s plus 4 plus L inverse of 1 by s power 2 plus 2 power 2 plus s by L inverse of s by s squared minus 3 squared. So this is going to be t plus this is going to be e power minus 4t. The third term will be in the form of sin at by a. Here a equal to 2. So I can write sin 2t by 2 plus the last term will be cosine h at. Here a equal to 3. So this will become cosine h 3t. Question number 3. L inverse of 3s by 3s plus 5 upon s power 2 plus 7. So we have to take L inverse for this one. So this I can split into two terms. How? We have to first write L inverse of 3 by s squared plus 4 Then the second term will be L inverse of 5 by s squared plus 7. Now from the first term, take this constant outside from L inverse. From the second term, take this 5 outside from L inverse. And also, if you see the denominator, we have 7. But what is in the denominator? The denominator should be in the form of s power 2 plus a power 2. So in place of a power 2, I have only 7. So I have to write 7 in the form of a power 2. So I have to write number 7 as square root of 7 the whole power 2. Because square root and squared cancel, we will get again 7. So this 7 I am going to write square root of 7 the whole square. Now applying L inverse, this will become cosine square root of 7t, and the second term will become sine square root of 7t divided by square root of 7. Question number 4, we have given two terms. I have to apply L inverse for this term. I have to apply L inverse for this term. In the first term, let me take 5 outside. From the second term, let me take 2 and 3 outside. So we have 5 into L inverse of s by s squared plus 3 squared, and the second term will become 2 by 3 L inverse of 1 by s power 4. Now apply L inverse for this one. This will become cosine 3t, and second term we have L inverse of 1 by s power 4. So that is going to be t to the power 3 divided by 3 factorial. Already outside I have 2 by 3. So this will become 2 by 3 t power 3. We know that 3 factorial is nothing but 3 times 2 times 1. So it will be 3 times 2 times 1. So this 2 and 2 gets cancelled. 3 times 3 will be 9. So the final answer is 5 cosine 3t plus t to the power 3 over 9. Question number 5. Again, I have to split the given problem into two terms. So this is going to be L inverse of 3s upon s power 2 plus 5 power 2 plus L inverse of the second term, that is 2 by s power 2 plus 5 power 2. From the first term, take 3 outside. The remaining terms are s by s power 2 plus 5 power 2. From the second term, let me take 2 outside. So we have 2 into L inverse of 1 upon s power 2 plus 5 power 2. So this is going to be 3 cosine 8t. In place of a, I have 5. So this will be 3 into cosine 5t. Plus second term, it becomes 2 times sine 8t by a. Here a equal to 5. So I can write sine 5t divided by 5. Like Laplace transform, in Laplace inverse also I have a property called shifting property. We know that L inverse of f of s equal to f of t. Then I can write L inverse of f of s plus a is equal to e to the power minus at L inverse of f of s. Similarly, I can write L inverse of f of s minus a is equal to e power at times L inverse of f of s. Let us discuss some problems based on this shifting property. Question number 6, L inverse of s minus 1 divided by s minus 1 power 2 plus 9. 9 I can write 3 power 2. So what I do, first see this one. We have s minus 1 and we have s minus 1. So this is going to be e power at. Here a value is t, so I can write e power t. Then L inverse of, after replacing this into e power t, s minus 1 will become s. The denominator also becomes s power 2 plus 3 power 2. Now this is going to be e power t. If I take L inverse for this, this will be cosine at. Here a equal to 3, so I have cosine 3t. Question number 7, L inverse of 4 divided by s power 2 minus 2s plus 5. So in step number 1, let me take this constant outside from L inverse. So we have 4 into L inverse of the remaining term. Then in the denominator, I am going to add minus 1 plus 1. Then these first three terms, s power 2 minus 2s minus 1, I can write s minus 1 the whole square. Then minus 1 plus 5 will become plus 4. This 4 I can write 2 to the power 2. So we have now 4 into L inverse of 1 by s minus 1 power 2 plus 2 power 2. So see the denominator, I have s minus 1. So this is going to be 4 e power t. Then we have the remaining term 1 by s minus 1 the whole square now will become s power 2 plus 2 power 2. So this is 4 into e power t. By taking L inverse, this is nothing but sine 2t divided by 2. By cancelling 4 and 2, we will get the final answer as 2 into e power t sine 2t. Question number 8, L inverse of 5 by s plus 2 the whole square. So step number 1, take the constant outside. So we have 5 outside, then we have 1 by s plus 2 the whole power 3. Then this s plus 2 will become e power minus 2t, and this will reduce to s. So s to the power 3. So I have 5 into e power minus 2t. By taking Laplace inverse, it becomes t. See the power here. If the power is 3, here we will write 2. That is 3 minus 1, 2. Then whatever in the power, that value factorial. So this will be 5 into e power minus 2t, t power 2 by 2 factorial is 2. So final answer 5 by 2 e power minus 2t times t power 2. Question number 9, a simple one. See the denominator, we have s plus 1 the whole square. So this is going to be e power minus t, and then this will reduce to s. So I have s power 2 plus 1. So this is e power minus t. This is nothing but sine at by a equal to 1. So sine t divided by 1. So this is nothing but e power minus t into sine t. Question number 10. We have L inverse of s by s plus 2 the whole squared plus 1. If you see, in the denominator I have s plus 2, but in the numerator I have only s. So I want to write the numerator also in the form of s plus 2. To write numerator as s plus 2, what I am going to do, I am adding 2 and subtracting 2 in the numerator. Then I am keeping the denominator as it is. Okay, now the next one will be L inverse of, we will write this as our first term. Okay, so we have s plus 2 upon s plus 2 the whole squared plus 1 plus L inverse of the remaining term. What we have remaining, minus 2 upon s plus 2 the whole squared plus 1. Then as usual, see the numerator, we have s plus 2. In the denominator also we have s plus 2. So this is going to be e power minus 2t. L inverse of s plus 2 now will become s. Denominator also will become s power 2 plus 1. From the second term, let me take minus 2 outside, and this s plus 2 will become e power minus 2t. Then I have L inverse of 1 by, this will reduce to s power 2 plus 1. So the final answer is e power minus 2t. This will become cosine 2t minus 2 into e power minus 2t, and this will become sine at by a. Here a equal to 1, so I have sine t. So we have two terms. So let me take e power minus 2t as a common factor. Then we have e power minus 2t cosine 2t minus 2 into sine t. So this is my final answer. So I have given some 5 problems for you to work out. Check the answer with the solution. Thank you. See you in the next video. I think here this is not the right answer. You can check yourself. This is not the right answer. Check yourself.